Okay, so we're going to continue looking at solving systems using elimination. Remember, the other two methods that we learned are graphing and substitution. Nothing wrong with substitution, it's just that sometimes that method takes a little bit longer to do, and elimination is an easier method. Okay, so that's why we're using that. How do equations have to be set up when we're doing elimination? Like when we're graphing, you want y equals mx plus b. But when we're doing elimination, can somebody remind me what's the pattern that you want? Yeah. So x, yeah. And what comes after that? Could be a plus or a minus. Yep. Then the y. And equals, and what's on the other side? Number. Just the number without any letters written. Yep. So x plus or a minus, the y equals, and then the number. Yep. Okay, so remember in situation 1, we already have this. Okay, I don't think, do you have to write that in yet? No, not yet. So you already had problems that had same number, same letter, different sign. Okay, so the first type of problem we did yesterday was something like this. What is going to cancel out there if I were to solve that? The 4y and? Yeah, because you already have the same number, same letter, opposite signs. Okay, so that would cancel. So that's the first type that we looked at. And then the second type, something like 3x minus 5y equals 6, and 2x equals 4 minus 5y. Now, if we look at that one, do we have the same letter, same number, opposite signs? No. The way it's written right now? No. But if we fix it, so we put the 5y on the other side, how would this negative 5y move to the left? You would add it. Yep. So if we fix this equation, it would become 2x, and we would add the 5y to the other side. And what would be left on the right side? 4. Yep, just the 4. Now, if you look at this one and this one, do those have same letter, same number, opposite signs? Yeah. Yeah, once you fix it, they do. Okay, so those are the two kind of cases that we looked at for situation 1. Okay, pretty much already had what you needed. You didn't have to do any kind of multiplication. Okay? Today, we're going to have to do multiplication to fix it so we have what we need. All right, so situation 1, we already wrote down in the guided notes yesterday, so I'm not gonna write that one again. But remember, you're looking for same letter, same number, opposite sign, and you just add the columns up, and they cancel out. Okay, so that's already on your guided notes. All right, so today we're going to solve with situations 2 and 3. Okay, so this is the first thing you need to write down. It says, so our chart is going to look a little bit different because, and on the first blank, you're going to put we have to multiply. So we're going to have to do some multiplication first. And then on the second blank, you want to put, but we still need to make sure the equations are lined up. Remember, lined up means x's plus or minus, y equals, and then a number. So let me show you an example of what it means to multiply in an equation. And I think we did one in the warm-up yesterday. All right, let's say we put a 2. And then I had the equation like 3x plus 4y equals 5. What it means to multiply an equation by a number is it means to take a number and distribute it to everything. So if I took this entire equation and doubled it, instead of 3x, what would I have? 6x, yep, and then plus 8y, and then equals 10. And the reason why you might have to multiply by a number first is because, let's say you had an equation like this. And you were trying to get the x's to cancel out. Well, if you look at the original one, does what's in that red box and what's in the blue box have the same letter, same number, and opposite signs?
Yeah.
No. If you look at the red and the blue box, you've got a 3 for the x, so do you have a negative 3 over here? No. You've got a 4 for the y, so do you have a negative 4 over here? No. And then a 5 and a 12. So these equations don't have what we had yesterday. But look what happened when I doubled the red one. I have a 6x and a negative 6x. So by doubling this equation, I turned it into the kind of problem we had yesterday. Now I have same letter, same number, opposite sign. One's a negative, one's a positive. So that's the extra step that we're going to have to do today. And sometimes the tricky part is just figuring out, well, what do you have to multiply it by? Right? So that's what we're going to try to break down in situation 2 and 3 to make it as simple as possible to figure out what this number has to be, because they don't tell you that. You would have to figure out that it's a 2. All right, so just looking at the template. This is the template we used yesterday in the top. This is the template we're going to use today, okay, in the bottom. Does anybody notice what's different about them?
There's like an extra box.
Yeah, there's these extra 2 little boxes here. And because these boxes are here, that box is going to contain this number. It's the number that you're going to have to multiply the equation by. Right? So that's what that extra box is there for. Everything else is pretty similar, okay? But that's the only extra step. And notice box 1 is a little bit smaller because we're going to pretty much do all of our work in box 2. All right? We're not going to do anything in box 1. The only thing we're going to write in box 1 is the 2 equations, and we have to make sure that before we put them in this box, they're lined up. Okay. All right, so the bottom one, that's the template we're going to be using today. All right, so let's look at situation 2. So under situation 2, you're looking for a single positive variable in both equations. Okay, so let me give you an example. 4x plus y equals 5. And let's say 2x plus y equals 7. That's an example of a problem that would fall under situation 2. I'm not going to solve that, but that's an example. We don't have same letter, same number, opposite sign, but we have something pretty close. We have same letter, y and y. What number is in front of each y, even though it's not written? 1. So we have the same letter, same number, same sign. That's not what we want. Okay, but it's close. So what we would have to do to fix this one is multiply everything in one of the equations. Doesn't matter which one you pick, top or bottom. But multiply everything in one of the equations by -1. So let's just try that step on this one. Which equation here do you want to multiply by -1?
Wait, does it matter?
It doesn't matter.
Bottom.
Which one?
Bottom.
Bottom? Okay, let's do the bottom. So what I'm going to do is put a negative 1 on the outside. And I'm just going to multiply it just like that. Let's do it to see what happens to this. Okay. When you multiply negative 1 times 2x, what do you get? Negative 2x. How about when you multiply negative 1 times y? Negative y. And what about negative 1 times 7? Negative 7. Now, we didn't do anything to the top equation. So that one pretty much just gets copied over the way it is. 4x plus y equals 5. Now, excuse me. Thank you. Now, if you look at the problem, if you were to add everything up now, what would cancel out?
The Y's.
Yeah, the y's would cancel out. If you added them up in the original problem, would they have canceled?
No.
No, because it was a positive y and a positive y. That's 2y. But by multiplying everything by negative 1, you fixed it so that now when you add them up, something cancels out. All right, so now we'll practice a few of this kind of problem. So let's try example 1a. So when you start to do these problems, what I would do is look at your different situations and go through them in order. Situation 1 is the easiest. Situation 5 is going to be the hardest. Okay? Start with the easiest situation and see if that's your problem. If it is, then you do it. If it's not, then we go to the next situation. All right, so let's look at example 1a. I want to know if this is situation 1 from yesterday. Do I already have same letter, same number, opposite signs? If I do, I can just add the columns up right away. So what do you think? Do I have same letter, same number, opposite sign? No, I don't. So then we have to go to situation 2. Do we have a single positive variable in both equations?
Yes.
Yes. Which variable, single means there's like a 1 in front of it. Which variable is positive in both equations and has a 1 in front of it? Y, exactly. This is what tells you in situation 2. Okay. So what does it say to do when you have situation 2?
Multiply everything in one of the equations by negative 1.
Multiply everything in one of the equations by negative 1. Doesn't matter which equation you pick. All right, so you want to pick the top one or the bottom?
Top.
Okay, so we're going to multiply everything in the top by negative 1. So let's put this in our template now so we can start to organize what we're going to do. Before we write them in the box, they have to be lined up. X's, Y's, and then the number. Are both of these equations in the right order?
Yes.
Yep. So we can copy them down right here. So x plus y equals negative 3. And 4x plus y equals 2. Now, which equation did we say we're going to multiply by negative 1? The top. So what I'm going to do is I'm going to put a negative 1 in that top box. That's the number that's going to get distributed, just like that. You're not going to multiply the bottom one by anything. So what I'm going to do is I'm just going to cross that box out, because I'm not using it. The box that you cross out and you're not using, that equation stays the same. So we're going to copy equation 2 over right here. Now equation 1, we're going to multiply this out, and then we're going to write down the answer on the right side. So let's start with what's negative 1 times negative x. What is it? Yep, positive 1x. Marie, what's negative 1 times y?
Negative y.
Negative y. And Eli, what's negative 1 times negative 3?
Positive 3.
Positive 3. Yep. Now, if you did that step correctly, you should be able to add these up and something should disappear. All right, let's see. All right, let's add up the x's. Maddie, what's x plus 4x? Yep, 5x. And Lily, what's negative y plus y?
Positive? No. How I get confused with the negative and positive? What's the negative?
So it's like negative 1y plus 1y. Or think of it with numbers, like negative 1 plus 1.
Zero.
0.
Yeah.
Okay. So negative 1y plus 1y is 0. That's the whole reason we multiplied by negative 1. And I didn't write this part down, but we just eliminated the y. That's what we just eliminated. And we multiplied the top equation to eliminate the y. All right, so that's gone. Now we have equals. And Zach, what do I get on the other side here? Yep, so 3 plus 2 gives me 5. All right, so now I'm at my last step. Eric, what do I have to do in my last step?
1.
Yep, what do you divide by? Divide by 5. What?
X equals 1.
X equals 1, yeah. So you get x equals, and you got 5 divided by 5. That gives you 1. And that's your answer. All right. Any questions on that one? All right. Eric, you feeling all right? All right, so we got x. What do we still need to find?
The y.
Yep, still need to find the y. So in this case, we're going to get y equals, and now we have to take the x equals 1 and fill it back in. Sam, which equation do you want to plug 1 back into? Top one or the bottom one? I would go back to one of these two original ones.
The bottom one.
The bottom one? Okay, so we're going to take the 1. And we're going to fill that in right there. And Molly, can you tell me what the bottom equation will look like when I fill in 1 for x?
It'll be 4 times 1.
So 4 times 1, yep.
Plus y
Plus y
equals 2.
equals 2. All right, and now we just finish it up and solve for y. All right, so Eli, what's 4 times 1 going to give me?
4.
So 4 plus y equals 2. And then Molly, what's my last step?
Subtract that.
Oh, sorry, I meant Marie. But yeah, go ahead.
Subtract 4.
Yeah, subtract 4 from both sides. And now we have y by itself. And Marie, what's 2 take away 4?
Negative 2.
Negative 2. Yep. So we have x equals 1 and y equals negative 2. Okay, so not that many more steps than yesterday, but there was that one extra step where you have to multiply by negative 1 first. Eventually, this number is not going to be a negative 1. It might be like a 2 or a 3. Then it's a little harder to figure out what it is, but I'm going to show you that tomorrow. Okay, but for now, just multiply by negative 1. Okay, any questions on that? All right, I'm going to have you guys try example 1b. It is a situation 2 problem, so you're not going to be able to just add the columns up right away and have something cancel. Okay, you're going to have to do exactly what we did in the last problem. All right, take a few minutes, try it, and then we'll walk around. And when you get your answer, let one of us know, and we'll come check it. Okay, so first thing we do is check if this is situation 1. Do you already have same letter, same number, opposite signs?
Yeah.
You do? Okay, which letters can you add right away and they cancel?
Wait, what was the question again?
Do we have situation 1 here?
No.
No. It's not situation 1 because you don't have like a 2x and a negative 2x. All right, so then let's go to situation 2. Do we have the same single positive variable in both equations? What do you think? Do we have a single positive variable in both equations?
Yeah.
Yes. So then the what to do part, multiply everything in one of the equations by -1. All right. Now, are the equations already lined up?
Yeah.
Yes. So then we can copy them down. Yeah. So x minus 3y equals 18, and x plus 5y equals 2. Now, we didn't do one like this, but let's say they weren't lined up. Let's say that this top equation was x equals 18 plus 3y. Okay. We'd have something we have to fix there first. You have to fix it so this 3y is back on the other side. How would you put that 3y on the other side? Yeah?
You do x minus 3y.
Yes. Yep, you'd have to minus this 3y to put it back on the other side, and then it would look just like this. Okay. So here, they didn't give you one like that, but if they did, you have to fix it first, like we did yesterday. Put all the x's and the y's on the same side, then you can start the problem. All right, so all the x's and y's are on the same side, so that's perfect. We have to multiply one of these by -1. Which one do you guys want to multiply by -1? Top one or the bottom one? Bottom? Okay. So the bottom one is going to get multiplied by -1. And we're not using the top box. So what do we do to that box since we're not using it?
Cross out.
Yeah, we're just going to cross it out. By the time we get to situation 5, there will be numbers in both boxes. Okay, but for now, it's just going to be one box. All right, so we're not multiplying the top one by anything, so we're going to copy that one over. X times 3y equals 18. And Marie, what am I multiplying the bottom one by?
-1.
Yep, so we're going to distribute that -1 out, just like that. Eli, can you tell me what I get when I distribute that -1 out?
Yeah, -1x.
Yep.
You get -5y.
-5y,
And -2.
-2. Now, we should be able to add these up and something should cancel. Maddie, what's x plus -x?
Just x.
If you did x plus 0, you would get x. But this is 1x plus -1x.
Equal to 0x.
0x, yeah. They cancel out. Remember, if something doesn't cancel at that step, you did something wrong. Okay, something has to eliminate. That's why it's called elimination. Okay, so the x's are eliminated. How about if we add the y's up? What do we get when we add those?
-8y.
Negative
8y.
-8y. Yep. Equals. And when I add the numbers on the other side, I get 16. Sam, what's my last step to get y by itself?
Divide 16 by -8.
Yep. So divide both sides by -8. That's going to cancel out everything that's on the left. And then on the right, Lily, what's 16 divided by -8? -2. Yep. Okay. So now we get -2 for y. And Eric, what do I still need to find?
X.
Yep. Still need to find x. And Zach, how am I going to find x?
You're gonna find it by putting x minus 3y equals 18.
Okay, so you want to take the top equation, and what do you want to do with that?
You have to do 3 times -2.
Okay, so yeah, we could take this number and fill that in right there. So everything stays the same except for y. So you're going to have x, keep the -3. And Eli, what am I filling in for y?
-2.
-2. So put that right there, and then equals 18. All right. So Sam, what's -3 times -2?
+6.
+6. All right. So we get x plus 6 equals 18. And Maddie, my last step to get x by itself.
You subtract 6 on both sides.
Perfect. So subtract 6. And Marie, when I subtract 6 from 18, that leaves me with 12. Nice. And that's it. That's situation 2. So any questions on that one? All right. So now let's look at another one. This is going to be situation 3. So let's say I gave you, let me just give you an example of something first. Say we had 2x plus y equals 5. You don't have to write it down. I just want you guys to look at this one. And then 3x, let's say, plus 6y equals 10. Okay, let's look for and see if this is situation 1. Do we have the same letter, same number, and opposite signs right away?
No.
No. Okay, let's look for situation 2. Do we have a single positive variable in both equations?
No.
No. So this isn't situation 2. This is going to be situation 3. You have a single positive variable in one equation. Now, let's look at these. And let's say I wanted those to cancel out. What number is in front of the top one?
1.
A 1. What number is in front of the bottom one?
6.
A 6. What would this top number have to be if I wanted it to cancel out with the bottom number?
-6.
It would have to be a -6. So what we're going to have to do in this top equation is multiply everything by -6. And when you do that, this number turns into a -6. So what's the trick? Let me show you. So the way you figure out what to multiply by is it's the opposite of the number that's attached to the letter in the other equation. So I go back to this little example. We have a y. We're trying to get rid of it. Look at the y in the other equation. Look at the number that's attached to it. It's a +6 multiplied by the opposite of +6. The opposite of +6 is -6. And if you do that, it's going to make your letters cancel out. So situation 3 is when you have a single variable, but only in one equation, not in two equations. So you have a single variable, could be the x or the y, doesn't matter which one, but it's only in one equation. And then you multiply everything in the equation that has the single variable by the opposite of what that's attached to in the other equation. It's a little wordy, but it's easier when we look at an example. Alright, so that's the example we're going to look at. Okay, x plus y equals 2, and 2x plus 7y equals 9. And we're going to start with situation 1. Okay, that's the simplest one, and then work our way up till we figure out which one this is. Okay, situation 1. Do we already have two equations that have the same letter, same number, opposite sign? No. So we don't have that. So let's go to situation 2. Do we have a single positive letter in both equations? No. We don't have any single positive letters in the bottom one. We have a 2 in front of the x and a 7 in front of the y. So this isn't situation 2. Do we have a single variable in at least one of the equations? Yeah, which equation has a single letter in it? The top. Yep. So then that means this is situation 3. So it says multiply everything in the equation that has the single variable. So that means you're going to multiply the top one by something. You're not going to multiply the bottom one. So you're going to multiply the top one by something so that we can make a letter cancel out. Now, in this one you have a choice. Which letter in the top equation has a 1 in front of it?
Both.
Both. So then you can choose which one you want to try to get rid of first. You want to focus on the one that has just a single, like a 1 in front of it. In this problem, it's the y. In this problem, it's both the x and the y. So let's pick. Which letter do we want to try to eliminate? The x or the y? The x. All right, so we know what we're going to try to do. We're going to try to eliminate the x. Let's copy everything into our table. Okay, the template is the same as the last one. Okay, Eli, before I copy the equations in this box, what do I have to make sure of?
That the single variable is only in one equation.
So this goes back to something we did yesterday. So not something specifically, I mentioned it today, but we didn't learn
We
it
have to
today.
make sure that it's like the same number, letter, and sign.
Well, we can check for that, but we don't have that. This is not a situation 1, so we don't have same letter, same number, opposite sign. Does anyone else remember, what do we have to make sure of before we write anything in this box?
As in the right order.
Yes, that they're in the right order. Are these equations both in the right order?
Mm-hmm.
Yes, I'm going to give you one in the next problem where they are not in the right order. We're going to have to fix it first. Okay, so these are in the right order, so we can copy them in. X plus y equals 2. 2x plus 7y equals 9. All right, now, because they both have a single letter, you can pick either one. We said we're going to eliminate the x. So now, you're focusing on this. Don't worry about anything else. Just focus on what's in that red box. We want these to cancel out. What number is in front of the x in the bottom one? 2. So what number would we need in front of the top one so that these cancel out?
2.
-2. Remember, a 2 and a 2, that would add up to 4. So if there's a 2 in the bottom one, we need to get a -2 in front of the top one. How are we going to get a -2 in front of the top x?
Subtract the 2. Wait, no.
So you're going to have to multiply by something. What could you multiply the top equation by to get a -2? -2. Yeah. You're going to multiply the top equation by the opposite of the number in front of x in the bottom. Now, what if you wanted to get rid of the y's? Just think that through. What number is in front of y in the bottom? 7. So what number would have to be in front of y in the top for them to cancel?
-7.
-7. How would you get a -7 in front of that y? Do what?
Multiply equation 1 by -7.
Yeah. Now you can't do both at the same time. You have to pick one. Are we going to multiply by -2 or are we going to multiply by -7? We're multiplying by -2 because we're trying to eliminate the x's. Okay. All right, so that needs to be distributed up. So you have to distribute it to every number in the top. What are we doing to the bottom one? Are we multiplying it by anything? No. So we're just going to put an x in that box. We don't need it. And we're going to copy equation 1 over. All right. Now equation. So we copied over equation 2. Now we're going to multiply the top one by -2. What's -2 times x? So we're going to distribute out this -2 now. What do you get when you distribute -2 to the first term?
-2x.
-2x. Eli, when you distribute to the second term?
Yes. No. Yes.
So I'm looking for something with a number attached to it.
Oh.
When you multiply -2 times y.
Yeah. -2y.
-2y. Yep. Equals. And what about -2 times 2?
-4.
-4. Yep. Now, if you did that step right, we should have same letter, same number, opposite sign. The goal is to turn every problem that's not a situation 1 into situation 1. That's what we're always trying to do. All right. Now, the vertical dots, the line there, that's your reminder to add them up. So, Lily, what's -2x plus 2x?
Zero. No.
Think about it without the x's. It was like -2 plus 2. What would you get?
-4.
That'd be -2 minus 2. That would be -4.
So we're gonna be going down. That'll be 0.
0. Right? So negative 2x plus 2x, that cancels out. We get 0. How about when I add my y's up? Maddie, what's negative 2y plus 7y?
5.
Perfect. 5y. And Zach, negative 4 plus 9? 5. Yep. All right. So we almost have y by itself. Sam, what's my last step to get the y alone?
Divide 5 by 5.
Yep, so divide by 5 on both sides. And now we have y equals, and Molly, what's my answer?
Y equals 1.
Yeah, y equals 1. All right, so we got y. Marie, what do I still have to find?
X.
Yep, still have to find x. And Eric, how am I going to find x?
Then Y. Replace Y
Yep, we're going to replace y.
with the bottom.
Okay, you could do the bottom one. I think the bottom one is harder.
I think the bottom X is like, I would put it better.
Okay, you can, if you work with that one better, you can definitely do it. Does anybody know why I think the bottom one is harder though than the top one?
Because it's more.
Has more numbers.
Yeah, it has more numbers in front of it. Right? In the top one, it's just x plus y equals 2. You don't have to deal with multiplying by a 7 or anything like that. But you can pick either one, whichever one you think is easier. So I am going to do the top one this time though. So fill in 1 for y. So you have x plus 1 equals 2. And now you're left with a relatively straightforward equation.
Put like around it.
We don't really need parentheses because we're not doing any multiplying. If we were multiplying, then yes, I would put parentheses there. Like if you were plugging it back in with the 7, then I would do 7, and then in parentheses I would put 1, so we know it's multiplication. Because you can't write this. That would look like the number 71. Yeah. All right. So then my last step on each side, minus 1, and we get x equals 1. Any question on that one? All right, so I think we're going to do the last situation 3 together. I was going to do it kind of like I did the second situation 2 problem, but I think we should probably just do it together. All right, now remember, before you even start looking at the problem, we have to make sure that everything is lined up. So make sure that you line up your like terms. That means x's, y's, then the number. Okay, that's like a pre-step. It's before you even start the problem. You gotta do that. Okay, so you can write that down if you don't remember it, but I did mention it yesterday, and we've been mentioning it all along. So. All right, so we'll call this equation 1 and equation 2. Is there an equation there that's already in the right order, and we can just copy it into our table right now?
Yes.
Which one?
The bottom one.
Yep, the bottom one. So we can put, for equation 2, 5x plus 3y equals 13. Okay. Is the top one in the right order?
No.
No. Then before we put anything in this box, we need to fix the top one off to the side. All right, so it's just wherever you have a little bit of space to write. In the top one, what needs to be moved to the left side?
Negative 4x.
Yep. And how do you move negative 4x to the left?
Add it to the other side.
Add it to both sides. So negative 4x plus 4x is gone. What's on the right side now?
The equals and it's 7.
Yep, and then a 7. That's exactly what you want on the right. Now, tell me what would be on the left, but just make sure you put it in the right order.
4x minus y.
Yes. You have a positive 4x and you have a negative y, but you need to put it, think of it as alphabetical order. X comes before y. Now, is that in the right order?
Yes.
Yes. Now we can start solving the problem. Alright, so we got 4x minus y equals 7. Alright, let's go through the situations. Do we already have same letter, same number, opposite sign right away?
No.
No. So this is not situation 1. It's not the easiest problem we could have. Do we have a single letter in both equations? What do you think, Meg? No. So then it's not situation 2. Do you have a single letter in at least one equation?
Yes.
Yes. Okay. Then this is situation 3. Which equation has the single letter in it? The top one. So then you're not going to do anything to the bottom. So let's cross the bottom box out. You're always going to multiply the top one by a number. Now, look at the y's. What number is in front of y in the bottom?
3.
3. So what number do you need in front of y in the top one?
9.
You need a negative 3. So what could you multiply this by and get?
3.
Yeah, we're going to multiply it by 3. Right, so watch what happens when you distribute that. What's 3 times 4x? How much?
20x.
That would be times,
no.
if we multiply by 5.
12.
12.
X.
X. Yep. What's 3 times negative y?
Negative 3y.
Negative 3y. And what's 3 times 7? 21. What are we doing to equation 2?
Nothing.
Nothing. 5x plus 3y equals 13. And now add them up. If you add them and nothing cancels out, again, you need to go back and start over. Something's wrong. All right. First column, what's 12x plus 5x?
17.
Yep, 17x, perfect. What's negative 3y plus 3y?
They cancel.
They cancel. That's the part, that's why we call it elimination. Because that y's just got eliminated. And on the right side, what's going to be my constant?
34.
34. Yep. Okay, so now we got 17x equals 34. Zach, what's my last step on both sides?
Divide.
Yep. And what do you divide by?
7x.
Just 17. Yeah, just 17. So 17 is gone. And that comes out nice. You wouldn't think with those numbers it would come out, but it does. What's 34 divided by 17? 2. So we have x equals 2. And Sam, lastly, what letter do I still need to find?
Y.
Yep, still need to find y. And Eli, which equation do you want to plug back into?
The one on the bottom.
The bottom one? Okay. Can you tell me what my equation will be if I fill in the 2 I'm sorry, we're filling it in for x. That was my fault.
It'd be 5 times 2 plus 3y equals 13.
Equals 13. Very good. All right, Maddie, what's 5 times 2 give me?
10.
So I got 10 plus 3y equals 13. Lily, what's my next step?
You subtract 10. Or no, weird. You would. Oh. Would you subtract 10?
Yeah. You're
Yeah.
going to subtract 10 on both sides. So you're going to subtract 10. That's gone. Subtract 10. How about, Molly, what's still on the left side?
3y.
3y. And Marie, what's on the right side?
3.
3. Looks like we're going to get a nice answer. Divide each side by 3, and you get y equals 1. Yep. Okay, so that's the hardest problem we've done so far. We had to rearrange it first, and it was situation 3. Okay, tomorrow we will do situation 4 and 5. So just a reminder, part 2, that's the homework for tonight, 5.3. I will be after school on Thursday if you need to come and make anything up. If you can't come Thursday, you still need to get something done, or you need help, you can come any time during the day when I'm not teaching. So that would be periods 1, 4, and 9. I'm available.